Okay, so welcome people to this little mini series about RAG, Retrieval Augmented Generation, and we're going to be going through a series of notebooks which are going to take us through the basic concepts of RAG and start getting into the subject, have a look at the code. Now, the reason I'm doing this tutorial is because here we're dealing with neural networks, we're dealing with complicated systems, but there's a lot of stuff out there at the moment that's off the shelf. We can take it. You don't necessarily need to have a degree in data science to understand what's going on. And I think there might be many developers out there who understand code, can get their hands dirty in a little bit of Python, and can start to create some very interesting applications without worrying too much about the technical side. So we're going to be walking through how we can sort of optimize this RAG pipeline, and we'll get in the end towards the more technical aspects, and I'll at least show you guys where that leads. Now, firstly, RAG, what is it? Here up on the screen, I've got a very simple RAG application that I've developed, and this is as good an explanation as you're going to get. Essentially, this has got a large language model running in the background, and you can just choose whatever document, PDF document, you want to throw into this system. You throw the PDF document in, and then you can ask questions about something that might potentially be in that PDF. So you look at this is the query. What new features can help me share my work? And so essentially the system is then going to go and look in that PDF, is going to find the relevant parts of that PDF. And you see here we've got a number of sources. So this PDF behind the scenes has been split up into lots of smaller documents or chunks, and here it comes back with a suggestion of 1, 2, 3, 4 different documents, and we can still have access to those documents. We can see exactly what that part of the document said. Now, those documents are going to be closely related to the question, and behind the scenes there's a neural network making sure that happens, and we'll get into that very shortly. And then with all this information, we simply pass that on behind the scenes to the large language model, and we go, hey, look, here's a user question, here's information which is going to be useful to answering that question. Now use that information to answer the question. And so the large language model then provides a relevant response. And this is, of course, very, very useful because large language models by design are generators of tokens. They're generators of words. They're not generators of truths. So when it starts creating sentences and creating text, you can't necessarily rely on what's being said. And okay, we can put various safeguards in place to try and make sure that it is correct, but essentially we can't really guarantee what we're going to get out. Now, this whole idea of feeding the neural network with relevant information and then forcing it through prompting to rely on that information, or else it's just going to say, sorry, I don't have any information, I don't know what to do, it is very beneficial because we can see exactly where the information has come from. The large language model is not going to invent stuff, and so we introduce into the system a level of reliability, something that we can trust, and maybe something that we can start using in businesses and organizations. So this is why RAG is a major subject in artificial intelligence at the moment, and lots of companies are introducing these systems, putting them in place. Now, that's that was a very brief just overview of what RAG is all about. But just to show you what the end game might look like, I'm just gonna show you a little presentation. So here we're just imagining some sort of conversation between some guy who's at work and the artificial intelligence or the large language model. And so this guy is at work. He asks some sort of question: how are the sales of product X over the last 2 weeks? Now, I said we were dropping in a PDF before, but we can essentially hook the large language model up to any data source. And so the response to this by the large language model is, okay, yeah, I've got a sales query. Do I have any tools at my disposition that are going to enable me to answer this question? And he says, yeah, I do actually have a database. So what does the large language model do? It goes out, writes an SQL query, gets some information back from the SQL query from the database, uses that to answer the question. Okay. And so another question, well, can you compare some products X and Y over the last 2 months and then create me a visualization and then save the results? And these type of things that seemed maybe science fiction only a short time ago are reality, and they can be achieved. And so the large language model is going to go out, it's going to write an SQL query, he's going to review the results, he's then going to write some visualization code, which he's going to be able to execute and get some sort of response, which he's going to save in the working directory. He's then going to analyze those results and give some sort of feedback. Now, sorry, I'm not running this in PowerPoint, I'm running it in some other application, and it's gone a bit wonky, but we'll push on. So he saves this image in the working directory, gives some sort of analysis on what he's seen or what he's read. And the guy comes back, well, give me some descriptions of the product. Well, another tool that this large language model can have at its disposal is maybe some manual of procedures, which has got descriptions of all the company products, detailed descriptions of the specifications, etc. So having access to that tool, the large language model decides, okay, yeah, I'm going to go out and I'm going to have a look in these manual of procedures. We'll go into that in a little bit more detail in a short time. And he goes and finds the relevant products from the manual of procedures and then reports back the results. He gives the descriptions of the products. Have there been any negative comments? Well, yeah, we've had databases, we've had documents that we can connect the large language model up to, but also we can connect it up to an API. So imagine here, this LLM's got access to an API, a Twitter API, and he can go to the Twitter API, can do a search, come back with some results, and effectively answer the user's question. Moving on from that, you might have a question, well, what functionality do our competitors have? And the large language model says, well, okay, well, think about this, but I actually don't have any resources with which to answer this question. So maybe the best thing I can do is go out there and do a search of the internet, does a search of the internet, gets back some information about the competitors and their products, finds something relevant, and tries to answer the question. So essentially, this is how diverse it can get. I mean, of course, we can take a PDF, we can drop it in OpenAI, and it will be able to analyze that document. But if we create our own RAG custom system, we're going to have a lot more flexibility. We're going to have flexibility to link it up to different data sources. We're going to have flexibility to search documents by some metadata, for example. We're going to have the possibility of just looking at the documents that are a week old. And in addition to that, something that you're going to get off the shelf from OpenAI, if you've got some specific use case then it's very likely that you're going to be able to develop a system which is more powerful than anything that OpenAI is going to be able to offer, which has got maybe general usability, but is not been optimized for a specific task. In addition, of course, OpenAI is going to cost you. If you've got your own custom RAG system, you can have large language models, maybe not easily, but it's possible to have them locally. And in addition, you don't have to be paying, but you don't have to be sending off your customers' data to OpenAI. So there are a number of advantages in being able to create and tailor your own system like this. Now, I just want to talk for a second about numeric representations, because this is a concept which is fundamental, and we're not going to get too much into technical detail, but I think it helps to have some sort of concept of what's going on behind the scenes. So we have these types of neural networks. They're called embedding models or embedding networks. And these networks, all they do is they're going to take some text and they're going to transform that into a vector or a list of numeric values. Or maybe it's just going to be a list of numbers. It's going to be about 1,000 or 2,000 numbers long, and the values in this list are going to be somewhat abstract. We've got no idea what they mean, but they mean something to the neural network. But the purpose of this neural network is that if I have two similar sentences, when they're converted into these lists of numbers, then those lists of numbers are going to be similar. That means that these lists of numbers are going to be close if the text is similar, and if the text is dissimilar, then these lists of numbers are going to be far apart. That sounds very simple in prospect, but it's extremely powerful. These models work extremely well, and it's often astonishing at how well they do work. And so just looking at this visualization, then we see we've got some sort of sentence over here. That's transferred into a list of numeric values. And here we've got 1,000 numbers, but imagine if we just had two numbers. You could imagine plotting that on a coordinate system. And I've got a sentence about pizza and a sentence about cheese and tomatoes. Now, the neural networks is going to put those two close together, and a sentence about lakes and mountains, that's going to be a long way apart when we measure the distance between these numbers. So, essentially, that's what happens with the embedding model, and that's what enables us to search, to take a user query who writes some sentence about some subject. That gets converted into a numerical representation, and then when we check that numerical representation against numerical representation of, say, for example, a manual of procedures that we've split up into 200 different parts and got a numerical representation for each part, we can easily find, well, which is the closest to the user query. And it's like that we manage to check through a lot of text data and find the most relevant information. With that most relevant information, then we can pass that to the large language model. And that really is the essence of RAG. So I'll leave it at there. Next time, we're going to jump into the notebooks and we're going to start looking at how we can start coding up these RAG systems.